Let's take an example of a polynomial function and find its linear factors. Let's factor it. From those factors, we're going to find the real zeros of the function, and then we're going to discuss the multiplicity of those zeros. Okay? So when they say write the function as a product of its linear factors, they're telling you to factor this. Okay? Break this down into as many of these quantities as you possibly can. Okay? Now, when you look at factoring, we've talked about there's three different types of polynomials that we're going to look at factoring right off the bat. Binomials, trinomials, and quadrinomials, right, and higher. This is a four-termed polynomial. We have the odd degree of 3, and then the degree gets knocked down in each successive term, going all the way down to a floating constant. So a function that looks like this can only be factored by grouping. So we're going to take the first group, separate it from the second group. We're going to pull out the common factor from this binomial, which is x squared. If I pull x squared away from x cubed, I'm left with x. When I pull the x squared away from here, there's a -4. And remember that when we factor by grouping, whatever we get from this binomial, we write that again, because if this can be factored, and we're assuming it can, if it can be factored, this has to be x minus 4. So then I look at the negative 25x, get rid of that 1, we don't really need that. But we look at this negative 25x and we say, what do I need to factor away from this to be left with x? And that would mean we're taking out the negative 25, right? Now, does factoring negative 25 away from positive 100, does dividing this by negative 25, does that result in -4? Yes, it does. Okay, so we were able to factor this by grouping, and we take what was factored out, we put them together in a binomial, and then we take this repeated binomial and we only write that one time, right? If you want to review on factor by grouping, I've got a video, I've got multiple videos on that earlier in the unit. Let me know, I can send those to you. But this is not, and this goes to something we talked about in the previous video, these are not linear factors. This is not a linear factor because it's x squared. We would call this a quadratic factor, okay? But it is a special type of quadratic factor. It is a binomial that is the difference of two perfect squares. And the difference of squares can be factored down into, what's the C word? What's the C word? Did I get all those right? Conjugates. Let's see if I don't even know if I did the right number of conjugate. Oh, almost. All right, conjugates. Conjugates are the square root of that first part, the square root of that second part, one with a plus and one with a minus. Okay, so here is our product of linear factors. Check mark. Then find all the real zeros of the function. Now, we could do this the long way, and we could say, all right, set this equal to 0. And if we set it equal to 0, then that means each one of these factors is equal to 0, right? So that would become x minus 5 equals 0. That means x plus 5 could equal 0. It also means x minus 4 could equal 0. And we solve each one of these separately. This is always possible when you have your factored function, right? Set each factor equal to 0. But we talked about a shortcut in a previous video where we said, what if, as long as there's no coefficient here, right? No visible coefficient, the 0 from this factor is always the opposite of this number. So because that's -5, the 0 is 5. Because this is +5, this 0 is -5. Because this is -4, this 0 is +4. So here are our zeros, okay? Check mark there. We found all of the real zeros. Then state whether the graph crosses or bounces at each 0. This is related to the concept of multiplicity. When we're identifying multiplicity, we look at the exponential level. Are any of these factors or any of these zeros showing up more than once? No, they are not, right? We have 5 showing up here, we have -5 showing up here, we have +4 showing up here. So that would mean we're crossing the x-axis here, we're crossing the x-axis here, and we're crossing the x-axis at 4 as well, okay? You could even draw yourself a quick little sketch of what this might look like. Why not? We're here, might as well, okay? We have a 0 at -5, we have a 0 at +5, we have a 0 at +4. What else do we know about this function? It is an odd degree, and it has a positive leading coefficient. So we know that the end behavior from the rightmost 0 would go up and to the right and down and to the left from the leftmost 0. We cross at -5, right? Then we come back down eventually at 4 and we cross, and then we have to come back up and cross at +5. Okay?